Hello everyone. Can you see this book in front of you? If yes, that means this book occupies some space. Now let us try to pick it up. Is it heavy? Obviously yes, as it contains lot of pages, right? So students, when an object has mass and it occupies space, it is called matter. Other examples of matter are air, shoes, soil, almonds, cloth, pen, pencil, etc. So now we are going to start our first chapter, which is matter in our surroundings. And the first topic that we'll study is physical nature of matter. The first point under this topic is matter is made up of particles. For this, we have a very small activity. You have to take a beaker, fill half of it with water, add some salt to the water and dissolve it with the help of a glass rod. You will see that the salt has disappeared, but there is no change in the level of water. Can you say where has the salt gone? This can be explained by assuming that matter is not continuous, rather it is made up of particles. Salt contains a large number of separate particles. These particles, when dissolved in water, occupy the vacant spaces between the particles of water. That is why the water level in the beaker did not rise. The second point is the particles of matter are too small to be imagined. Again, the activity included in this one is you have to take 100 ml of water, add some crystals of potassium permanganate in it and dissolve it with the help of a glass stirrer. After dissolving it, you take 10 ml of the pink solution prepared in step 1, added to another 100 ml of fresh water. After dissolving, again take about 10 ml of the solution prepared in step 2, added to another 100 ml of fresh water. In this way, repeat the exercise 5 to 8 times. You will find that the last solution is still pink, though the intensity of the color has gradually decreased, as you can see in the diagram. This indicates that a few crystals of potassium permanganate are able to color an enormously large volume of water. This also shows that the small crystal of of potassium permanganate contains millions of small particles. The next point is the particles of matter are in constant motion. This is a very easy one. In this one, we have to put an incense stick in the corner of our house. You cannot get its smell from a distance. For that, you have to move closer to it. Now, light the stick with a matchstick. You can now get its smell even if you are sitting at a distance. And same goes with the hot sizzling food which is prepared in the kitchen. The particles of perfume present in the incense stick freely mixed up with the particles of air and have spread across the room. If the particles were not moving, the smell of the incense stick would never have reached you. The fourth physical property is the particles of matter attract each other. In this activity, you take an iron nail, a stick of chalk and a small piece of rubber band or a whole rubber band. Strike each of them separately with a hammer. You will observe that the stick of chalk gets broken to pieces easily. The piece of rubber band or the whole rubber band does not break so easily, but it is most difficult to break the iron nail. What do these observations say? It is clear that the particles of iron nail are held together by the strongest force followed by the rubber bands, whereas the particles of chalk have the weakest force of attraction. The last property is particles of matter have space between them. This activity we have performed earlier also. During the dissolution of salt in water, the particles of salt occupied the empty spaces between the particles of water. The empty space is called intermolecular space or intermolecular volume, and same goes with the lemonade. The lemon particles, they mix in between the water particles and give us a very tangy taste. Thank you.